Okay, I don't remember why I set the language to be English, but yeah, that's fine. The topic is running TFLite on your mobile devices. I'm a TensorFlow and mainly TensorFlow Lite contributor. Yeah, I sent some pull request to TensorFlow Lite before. We will go to a little bit more details later. And yeah, if you want to check the slide deck, you can check the QR code. It's already on SlideShare. Yeah, the opinions expressed in this slide deck is on my own, not my company or any other organization. Feel free to interrupt me anytime when you got a question. 可以用英文，可以用台语，还是用 Mandarin 问都可以哈。那我主要还是用英文讲一下也可以了哈。Okay, so who I am? I'm an old open source user. I use the open source stuff before the term open source is used or the term is coined. I learned to use Unix on X11 780, which runs 4.3 BSD at that time. Okay, I learned a lot of programming language, but not an expert in any of them. I worked on various system software before, such as CPU scheduling, power management, etc. And recently, I mainly working on performance engineering, which means to improve the performance of software. I contributed to TensorFlow Lite from time to time. So I was the original author of a command line utility of TFLite called label image. How many of them used TFLite or are interested in TFLite? You use the TFLite? Okay, it's good. So this is a mini computer. In case you don't know what this kind of mini computer was, the CPU of that X11 consists of TTL ICs. The CPU is not a microprocessor. So if you Google TTL chip, TTL stands for transistor logic, I think. And you can find one of the most famous TTL IC is the 74 series one. The first 74 series is an NAND gate, the basic logic gate. And you can construct a simple CPU with some TTL ICs. This is a simple one, but the X11 it's a more complex one, but still the CPU of X11 are all TTL ICs. Okay, so why TFLite? What is a TensorFlow Lite? TensorFlow Lite is one of the most TensorFlow. Let's talk about TensorFlow first. TensorFlow is one of the most popular machine learning framework. And TFLite is annoying. And TFLite is a lightweight framework. It's a lightweight runtime specially designed for edge devices. Originally, it's for mobile devices. What do we mean by mobile devices? It means your cell phone, your tablet. Later, the TensorFlow Lite is extended to IoT devices, or we may use the more conventional term called embedded devices. It's mainly for those microprocessors, instead of powerful MCUs, or say MCU microcontroller, instead of those more powerful embedded processor. Embedded is an ambiguous term, anyway. And one of the most powerful thing of TFLite is that the execution of a model by TFLite can be accelerated by the component on your SoC, other than CPU, such as GPU, DSP, and ASICs. So if you are kind of familiar with machine learning recently, so you may have heard about PyTorch. PyTorch is another popular framework by Facebook and the other guys. Yeah, it's popular, but it's not as popular as TFLite on mobile devices yet. Although there are some kind of PyTorch mobile, mainly it's a CPU implementation. No acceleration stuff yet. Okay. And then if you Google a little bit, you may find that there are many other open source neural network frameworks, but no one is as comprehensive as TFLite. You may want to check more about this on my previous slide deck. Okay, so what I'm going to talk about, we're going to give a quick overview of TFLite on Android and iOS devices. And there is a new, new kind of mechanism called TFLite metadata. And there is a corresponding TFLite Android code generator, which read the TFLite metadata and generate say Java or Kotlin source. And this could be useful for beginners. Or say even if you are you have some experience on TFLite, this kind of metadata and code generation can save your time if you start a new project. And as we mentioned, TFLite support accelerators, and those accelerators. How to use those accelerators on mobile devices? What TensorFlow Lite provides is a delegate mechanism. It's just the design pattern, and just like what the design pattern delegation is. Okay, as you probably know already, TFLite is a closed platform framework. It runs originally on mobile devices and then to IoT, and it runs on Android and iOS and Micro. Yeah. Why you want to use machine learning on edge devices? There are some typical arguments. One is the latency. I used to be a networking guy, so there's an older to call David Clark, who is a computer scientist in MIT. He said that there is an older network saying, bandwidth problem can be cured with money. Latency problems are harder because the speed of light is fixed. Okay. So if there is wireless transmission, and there guaranteed to be latency, right? So if you have a low latency requirement, you don't want to send it to cloud and get it back. And there is network connectivity problem. Although I heard the term always on back from 3G days, but we know that always on is not always true. Okay. And if you want to preserve your privacy, you probably don't want your data to be sent to the cloud. And your cell phone, your mobile device usually has more sensors than your computer, and those sensors can sense nearby environment, get a kind of ambient data, so that it could be useful. Okay, TensorFlow Lite started from Q4 of 2017. It grew from 20-something operations to more than 125 operations. And there are more and more data, more and more features. So if we check the features listed here, you can see that there are originally it's mainly for convolutional neural network, and the RNN stuff is a latecomer. Control flow was not supported in the beginning. Beyond that, you can see a lot of there are several items mentioned, quantization stuff, and you can see a delegation, and then API and stuff, and the microcontroller is here. It's kind of what we have right now. So I said that we are going to talk about metadata and the delegate, but what you may want to dig more into, if you want to squeeze more performance from your mobile device, you may want to learn more about the quantization, what fixed point operations and the integer operation on that. And as you probably know, newer ARM CPU support data product instruction, and Apple's new CPU, not the latest one. The A14 is coming, but the A13 has a kind of customized matrix operation support. It's kind of custom instruction. And for the GPU delegate, originally it supported 14-point operation only. So you can only run 14-point model using delegate. But recently, I think a couple months ago, the GPU delegate started to support quantized model. And there are more new stuff upcoming, especially one of the most interesting stuff is MRR-based runtimes, such as the TensorFlow runtime, TFLite, and ERI. I don't remember what ERI stands for. Okay, so I'll talk about TFLite tomorrow in another session. So if you haven't tried TFLite, how do you start to use TFLite? TFLite actually has two parts. The interpreter is used to load and run a model for you, and there's a converter. Converter is used to convert a TensorFlow model to TFLite model. Why we need two kind of format? You can find a related document in TensorFlow side. Nowadays, the documentation of TensorFlow and the TensorFlow Lite are kind of more complete, more comprehensive than, say, 4 or 5 years ago. And there is a good guide on how to load a model and do inference on devices using the TFLite interpreter. It covers how to use Java, but the Java is mainly for Android. Okay, it's not for general Java, and the Swift or Objective-C on iOS devices, and C++. The main part, the underlying interpreter is written in C++. So there's C++. Other APIs are just kind of wrappers around the C++ code. Either it's directly code C++ stuff, or use kind of foreign function invocation. Okay, so how do you load a model and load and run a model in C++? You have to load so it's basically to load the model, build the interpreter, and resize the input tensor if it's needed. Okay, and then you fill the input. You probably want to say copy the input image into the input tensor, something like that, and then code invoke. Then you can run it. Okay, the metadata part. So why the TFLite metadata is useful? So before this TFLite metadata was introduced, if you want to run a model, you have to kind of figure out what the model is for and what the format of the model is, what the output format of the model is. And if you tried that before, you probably know it's doable, but it's kind of annoying, I can say that. So you have to figure out different image processing and the normalization stuff. And in TFLite metadata, there are 3 parts. It includes model information, input information, and output information. And we can so you can write the information about the input and the output types into the metadata. Currently, supported data type are features and images and the bounding box. So these are general features. This is for probably for image classification as an input or image, any kind of image processing. So such as classification, object detections, segmentation, etc. But all of them usually need image input, so you can set the input type to be image, and for models such as object detection, the result probably has a bounding box, so you can check bounding box, and then it can tag associated file. So if you tried to run classification model before, you probably know that label files is not usually label file or files are not included in the model, in the TFLite model before metadata. So you have to prepare it separately. With metadata, you can embed labels and related information into the metadata, and you can cover the normalization and quantization info. And so with the example in this URL, you can find something like this. This is a Python script and to fill the metadata, and you can find more details in the guide to image input, label output, etc. And yeah, and there is a tool in Android Studio. I think this is only supported in a preview version. I don't remember which preview version of Android Studio support this, but yeah, you can see that when you embed, you put the information into metadata, and then load the data into Android Studio, you can see what the model information is. But this is not new. This is new for Android this year. But this, if you try the CoreML is iOS's machine learning framework. It was there from the beginning of the CoreML, about 3 years ago. Okay, so this actually works. So when I saw this in the TensorFlow Developer Summit this year, I kind of excited, so I tried to write a simple example as an exercise. So yeah, so I use the Camera X tutorial as a starting point. I know nothing about the camera stuff, so I started from the Camera X tutorial and imported the metadata, and in the metadata you can see there is information like this as an example. Show me how to do that after I put the information and run the load gen. And then I can just follow the example and put the related code into my little program, and it runs. It runs. Okay, as I said, a TensorFlow Lite delegate is a way for TensorFlow Lite to offload the computer to you want computation you want to do into a specific accelerator. Because why you need this kind of delegate or say offloading? Because running and the model is kind of computation intensive, and you don't want to occupy your CPU. On Android, the most popular, or say it's there. You don't have to install or say have another kind of configuration to use it. Is the neural network API, Android NNAPI, and TFLite has an NNAPI delegate from the very beginning of the TFLite, so that you can use the GPU with either GLES or OpenCL or Metal on iOS devices. And there are two interesting delegates. One is XNNPACK, which is XNNPACK is interesting CPU acceleration library, especially for floating point. I'll skip this because of time, but if you are interested, you can check the XNNPACK's paper. To use XNNPACK is actually quite easy. This is what I did in the label image. You just call a wrapper of the XNNPACK delegate to create the XNNPACK delegate. Then you are done. You can use the delegate. This is from the evaluation, the tool evaluation stuff of the standard TFLite part. Another interesting delegate is the CoreML delegate, because before the CoreML delegate was introduced this year, you can only use CPU and the GPU on TFLite with TFLite on iOS devices, which means you cannot use the most powerful neural network accelerator. And yeah, with a couple lines of code, you can use the CoreML delegate. So if you are interested, you can check my example. And yeah, here is the concluding remarks. So TFLite is getting more mature and comprehensive. So if you haven't started using it, you may want to try from with the metadata and the code generator. Or if you just started a new project, you can try that. And to speed up the execution of the model, you have to get yourself familiar with TFLite delegates. And you have to figure out which delegate you want to use, because not all of the accelerators are created equal. That concludes my talk. So I think the time is up. So if you have any question, you can ask me after the session. Or do we have time for one question? 下一场是不是要开始？